Thursday, 26th. This is our 10th class session. This is week 5. We got 5 weeks done. NET-142, Network Essentials, everything was about IP addressing today. I mentioned the OSI model, but we worked primarily on this. So we did a binary to decimal, decimal back to binary. We didn't get time to do the hex, but we'll do that on Tuesday. Routing, we talked a little bit about that. We got more to cover on that. We did talk briefly about private and public IP addresses. We've talked about DHCP in the past, but we haven't gotten to that yet in this part with the addressing. Packet tracer, we did an install and we did practice today. Eight bits gives us a byte. So what I did was I gave the students this number and I told them, can you give me the decimal? And it appeared a good share of them got it figured out. Yep. So here's how I would suggest to do it. The easiest way would be you can use a calculator to do the conversion, but you need to understand the addressing. So understanding internet protocol and the addressing is best done if you do it by hand first and then use easier methods later on. So here's how it works. So I rewrote this number underneath these, and then we have 2 to the 0. I'll use a different color up here. So that's 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth, 64. 2 to the seventh, 128. And pretty much for this, those are the only things we're going to need. You're going to need this much, and you'll learn that later on. We'll talk about it. So we took this address and I just filled it in underneath. Some of you could probably do this in your head, but I'm doing it by hand. Make sure you get it right. So we have one group of 32, right? So I wrote that down. And we have one group of 8, so I wrote that down. And we have one group of 2, one group of 1, and then we added them up. So 43 was the right answer. That's the decimal equivalent of this here number in binary. So then I asked a student for an address on their computer. So they gave me this address, and then we converted it. And the class did it in groups. One group did this conversion, another group did the 31, another group did 1, that one was pretty easy, and another group did the 12. So this is what the computer and computing devices and so forth look at. We write it like this here for us humans to understand. Okay? So then I asked them, what's their address out on the internet? And he said it was this one. So if you did like, what is my IP, or the best place to go look would be Aaron.net, or you can just type it this way, Aaron.net. American Registry for, I don't know, something, You can look it up. But anyway, they manage the IP addresses. If you type in "what's my IP," it'll show up, but it'll be one of these other websites that want you to click on their stuff so they can sell, monitorize their website. And what they do is they basically go here to get it, because this would be the place to have the right one and where you get it. Okay. So that's the address there that we use out on the internet. Okay, this address up here is what we use for NIAC. So this address is internal to NIAC. This address is public to the internet. So this address is a public, this address is a, let me back up there. This address is a public address. This address is a private address. You can use private addresses internally, and then you convert them using network address translation. I'll write that down here. Network address translation. Convert it to a public address to use out on the internet. These are the private addresses that can be used internally. These are not used out on the internet. Got it? There, there. And you've seen these before. We use them internally. Okay. Oh, by the way, how did the students change 172 to a bunch of ones and zeros? Well, if you took 172 and let me use a different color here. It's green. If you took, I use blue, 172 and subtracted 128, that means you'd have one group 128, and then we have 44 left over. And that would be 0 groups of 64 and 1 group of 32. 0 groups of 64, 1 group of 32. So we subtract that and we get 12. 0 groups of 16, 1 group of 8, 1 group of 4. Get it? When you enter 0, now you have the bits. We'll keep practicing. Alright, so inside these clouds, places, they can use private addresses. In fact, if you were going just from one cloud to another through a service provider, you wouldn't have to use public addresses either. You could use all private addresses because it's only your equipment seeing your equipment. If you're going into the internet, you got to use public addresses. That's the only way it's going to transfer the information. Alright, so these locations, they do NAT in between to convert it. And where do you get a public IP? You get from your ISP. Okay. So, side note, we listened to Danny Hillis. I think I spelled that right. It was a TED Talk. It was pretty good. I wrote a couple things on the board, trust, domain names, but there are a lot of stuff. It's only 12 minutes. You can look up TED Talk, look up Danny Hillis, and it's Plan B we need for the internet. That's it.